Those that visit or live in coastal regions have the opportunity to observe the rhythmic rise and fall of the sea that we call the tides. What is responsible for this ever-repeating cycle of advancing and receding water? Tides result from the interplay of gravitational forces from the moon on Earth, the sun on Earth, and Earth's daily rotation. To better understand how gravitational forces produce tides, a thought experiment will help. Imagine that we place a number of masses in a circular pattern high above Earth and allow them to fall in response to Earth's gravity. What will happen as they fall? First, let's consider these two masses, one directly above the other. Since the lower mass is closer to Earth, the gravitational force acting on it is slightly larger than on the other mass. As they fall, the distance between them increases. Next, consider these two masses side by side. Gravitational forces pull objects towards Earth's center. Therefore, as they fall, they move closer together. As all of these masses fall together, their original circular pattern becomes oval in shape, stretching vertically and compressing horizontally. The gravitational interactions that result in this vertical stretching and horizontal squeezing are known as tidal forces. When an object such as a satellite, moon, or planet is in orbit around another object, its orbit is the result of two separate motions. One is a sideways motion at constant speed, and the second a falling motion towards the object being orbited. The sideways motion results from the object's inertia and does not affect the falling motion. Thus, the tidal forces act on objects in orbit. But how is Earth falling? We normally speak of the moon orbiting Earth. In reality, both Earth and moon orbit around their common center of mass. The center of mass is the place where the objects would balance if they were on a teeter-totter. The center of the mass of the Earth-Moon system is actually within Earth, about 3/4 of the distance out from the center. As Earth falls towards the moon, tidal forces cause surface water to flow into an oval shape around Earth. There are two regions on our Earth that have higher than average water levels. They are towards and away from the moon. There are also two regions that have lower than average water levels. These are at right angles to the moon. As Earth rotates under these tidal bulges, locations on Earth experience high and low tides over the course of a day. If Earth were a perfect sphere covered by an ocean of uniform depth, high tides caused by the moon would be 14 inches higher than average. Low tides would be 7 inches lower than average. Local geography, such as the shape and size of a bay, can either greatly amplify or nearly eliminate the rising and falling of ocean water. In one particular location, the Bay of Fundy in Canada, the water level variations exceed 30 feet or 10 meters. Tides are also produced by Earth falling around the sun. Solar tidal forces are about half as strong as tides generated by the moon. At full and new moon, solar and lunar tides reinforce each other. These larger than average tides are called spring tides. At first and third quarter, solar and lunar tidal forces work against each other. These are known as neap tides. Other complications, such as the geometry resulting from the tilt of Earth's axis, can also vary the height of successive tides at a particular location. So, if you enjoy watching the rise and fall of the sea or enjoy the variety of life that flourishes with the ebb and flow of ocean water, look up and thank the moon.